This is part 3 for lesson 4.2, Linear Inequalities and Systems. So to finish this up, we're going to do a couple of other systems of inequalities. And so the next 4 problems, you can go ahead and pause the video. You're going to try to do them, come back to check, make sure you're doing everything right. You want to make sure you got the solid or dashed lines, you've got the correct slope, the correct y-intercept, and that your shading is happening in the right place. So come back when you're done with the next 4 problems. For number 21, you notice that both inequalities have the same slopes, and so I know I have parallel lines. Now, when you have parallel lines, if you're talking about systems of equations, they never touch, and so that's going to be no solution. With inequalities, sometimes it's no solution, but sometimes it's not. In this case, do I have shading that's overlapping? And the answer is yes, I do. I have shading that's overlapping in between the 2 lines. So there are solutions to this system of inequalities. So you're not going to write anything. You don't write anything other than what you would do on the other one. Just show the graph. But ask this question, what does no solution look like? If where the shading overlaps is the solution, what would no solution with inequalities look like? So speaking of no solution, if you look at this picture of number 22, they both have the same slope. So these 2 lines are parallel as well. They're both dashed lines, but on this one, the shading never overlaps. You've got above the one, below the other. They're never going to overlap. So this one is no solution. So the difference here is you actually need to write no solution. And you have to write that because I need to know that you know that that's what this means. So we're not writing our solutions in set notation or anything like that, because with inequalities, we don't really do that because it's just the graph speaking for itself. So the only time you're going to write something is when it is no solution, and you can just write out no solution. Okay, for number 23, in case you're watching this because you got stuck and you didn't get to it, what you're going to do is you have to put both of these inequalities into slope intercept form. So I'm going to take this first one, and I need to solve it for y. So if I have this, I'm going to subtract my 5x. I'll have negative 3y is greater than negative 5x plus 6. I'm going to divide by negative 3. Everything gets divided by negative 3. And when I divide by negative 3 on inequalities, I have to flip my sign. 5/3 x, and then 6 divided by negative 3 is negative 2. So that's what I'm going to graph. Okay, I'm going to erase this part except for the answer, and I'm going to take the second inequality, and I'm going to solve that one. So on the second one, I'm going to add x. So I'll have 4y is greater than or equal to x plus 8. I write it like that so it's in slope intercept form. I'm going to divide everything by 4, and remember it means everything. So y is greater than or equal to, this is 1/4 x plus 2. So that's the second inequality that I'm going to graph. Okay, now trying to keep this straight, just to make sure my colors are coordinated, I've got my first inequality in green. My second inequality will be in purple. So going to the green one, I'm going to go to negative 2. I'm going to go up 5 and over 3. And then do it again. I'm going to have a dashed line. And then it says less than. Please do not look at that one up there because that wasn't ready to graph yet. You have to look at the one where it was ready to graph, so down here. So it says less than, so I'm going to be shading that part of my graph. Okay, the next one in purple, I'm going to start it at positive 2. I'm going to go up 1 over 4, down 1 backwards 4. I'm going to have a solid line on this one. And it says y is greater than. So greater than is going to be up here. So remember, I need to be able to tell where the dashed lines are and where the solid lines are. So you might need to go back and emphasize that. I need to be able to tell where the overlapping shading is. So you might need to go in and emphasize that as well. So I'm going to kind of just color over that part so that it's very clear. Now, sometimes on a graph or a quiz, the way that one of my computer programs that I use, it might just show the overlapped part, and so that's what that means if you see something with just the overlapped part. That just means that those are where my solutions are to the system. And so just so you know in case you see that. Okay, 24 is also like the other one where you had to solve. So in case you didn't do that on your own already, I'm going to come down here and do this first one. So 12x plus 4y is less than or equal to negative 16. I need to solve for y. So I'm going to subtract 12x. Pay attention to like terms or not like terms. I'm going to divide everything by 4. So all of it gets divided by 4. I'm not going to flip my sign here because I'm not dividing by a negative 4. I'm going to, just to avoid confusion, I'm going to graph that right now. So I'm going to have my negative 4. I'm going to go down 3 and over 1, up 3 and backwards 1. I'm going to have a solid line, and it is going to be graphed less than, so below. So think about which way is below. It's going to be on that side. So if you're having any trouble telling above or below, again, remember, think about this line being your roof, and if the rain was coming down, which side would you stand on to be sheltered? Okay, the second inequality, and I'll erase this work right here. Okay, the second inequality, we're going to get the y by itself, so I'm going to add 5x to both sides. So y is greater than or equal to 5x minus 7. So I'm going to come down here to negative 7. I'm going to go up 5 over 1. I'm going to have a solid line. And it says y is greater than. So greater than is above the line. So make sure I can tell that they're both solid lines. The overlapped part is where we have both red and purple. Okay, it's bordered by the purple line right there and the red line right there. So that's how I can tell where the boundaries are. The last part of this lesson is just a little application of inequalities. And so it says you're at Big Burgers, you only have $18. That's a limit that I have. So no matter what I buy, I can't buy more than $18 worth. So that gives me an inequality situation. I'm going to have to stay less than or equal to $18 no matter what I do. It says that a burger costs $3 and fries cost $1. So I have enough that I could go buy 6 hamburgers, or I could buy 18 fries, or I could buy some combination. Those are just kind of my outer limits. I could buy nothing and not spend any money. Now, there's a couple of other things that I have to keep in mind. It says I don't want to purchase more than 10 items. Maybe I can't carry more than 10 items. So could I buy 18 fries? No, because I can only take 10. So that's a limitation. So number 25, it says, write an inequality to represent the total cost is less than or equal to $18. So what do I write about the burgers and the fries being less than or equal to $18? So I'm talking about the cost of the burgers and the cost of the fries. So $3 per burger, $1 per fry, and it has to be less than $18. So it's going to be 3, it says X is burgers, so 3X, plus the cost of the fries has to be less than or equal to $18. That's my inequality to represent my money limitation. The next one I'm going to do, it says write an inequality to represent the total number of items purchased is no more than 10. So I'm going to write another inequality to represent my space limitation. I can only carry 10 things. So the number of burgers that I'm going to get and the number of fries I'm going to get, when I put them together, it has to be what? No more than 10. So less than or equal to 10. Those are my two inequalities. So now that I've got those two inequalities, it becomes like these other problems where you have to put them in slope intercept form and then graph them. So I want you to pause the video. I want you to put both of these into slope intercept form. I want you to graph both of them. You're going to label your x and y axis. So label both of those axes there, not with x and y, with words. And then you're going to graph that, and then we're going to talk about what it means. Okay, first I want you to see my purple line. I solved right there for y. So y is less than or equal to negative 3x plus 18. I want you to notice that I did not go beyond the borders here. And the reason I didn't do that this time, where in other ones I go past it, it's not really that important. But that's because in this one, it's not possible for me to buy negative burgers or negative fries. So I have definite boundaries on what I can do. So that's like a whole other thing that you can do with math and systems of inequalities, but it's called linear programming. It's just where you have all these different boundaries on things, limits to what you can do. Okay, I've got my red line there. I solved for y, so that one is y is less than, so I'm going to be shading down here. Again, I'm not going to go past my 0 limits because I can't do that. I can't spend less than $0. Can't buy less than 10 things, less than 0 things. So I've got that. One thing I wanted to point out is actually I didn't put arrows on my red, and I actually should not have put arrows on the purple. And again, that's because the limitations, this is a real problem. And so with reality, you can't sometimes go past a certain thing. So what I've got is I've got my overlapped region right here. So these are my boundaries right here. It's kind of like a polygon, a four-sided quadrilateral there. And that's what I can buy. Given my limitations, I can buy anything in the yellow part. Anything in red will satisfy, I can't carry more than 10 things. But that doesn't limit me to cost. So if I bought 10 burgers, that's less than 10 things, less than or equal to, but I can't pay for it. Anything in the purple is something I can pay for, but I can't carry 18 fries. And so things like up here and over here, they're out of my limits of what I can do. And so if I wanted to think about it like this, everything that's not within those boundaries I cannot do because of the limitations I have on money and on what I can carry. So basically anything in there, that's what I can do. Okay, now just to kind of make this easier to read, I'm going to erase what's in here, and I'm just going to keep the boundaries so that I can talk about it and make marks at the same time. You're not going to do that on yours, but I'm going to do this so that we can easily see what it is I'm talking about. Okay, so on number 28, it says list all possible combinations you could purchase. Now, since X is my burgers and Y is my fries, remember to label your X and Y axis. And this is the number of burgers I could buy and the number of fries I can buy. I already know how much they cost. That was not a question. So since X is the burgers, I could buy nothing. I could buy 1 burger, no fries. That would be right here. I could buy 2 burgers, no fries, 3 burgers, no fries, and so on, all the way up to 6 burgers, no fries. And the reason I have to stop there is because if I buy 6 burgers, I have no more money to buy fries. And so that takes care of all of these. Okay, now the next thing I'm going to do is I'm going to look at what else. I could buy no burgers, 1 fry. So no burgers, 1 fry. I could buy 1 burger, 1 fry. 2 burgers, 1 fry. 3 and 1. 4 and 1. Now be careful, don't get carried away. Make sure that you're doing the right things. 5 and 1. Can I buy 6 and 1? Can I buy 6 burgers and 1 fry? And the answer to that is no, because I don't have enough money for 6 burgers and 1 fry. So the next one, I can do no burgers, 2 fries. 1 burger, 2 fries. And so on. I'm going to keep doing everything with 2 fries. Now keep in mind that we've got our limitations to be aware of. So I can do 4 burgers and 2 fries. Can I do 5 burgers? Is that in my region? So I can just check real quick. 5 burgers, $3 each, that's $15, and 2 fries. Yeah, I've got enough money for that. So I can tell that that is within my region. If I had a thinner pencil and used a straight edge, I could easily tell that from my graph. Okay, the next thing, and we're going to move our way up here. So I'm going to go to 0 burgers and 3 fries. So this is listing all of the combinations of what I can buy. Kind of tedious, but it kind of illustrates what we can do. It illustrates that these points are all solutions. I cannot buy, oh can I? I can buy 5 burgers and 3 fries. 5 burgers would be $15 and 3 fries would be another 3. So that actually must mean this is right there on the border. So go ahead and pause the video, finish writing this out. I know it's tedious, but it's just a good illustration of what we are talking about. Okay, here's my list. And so just depending on what pattern you follow, I just started at 0, 0, and worked my way up from there. So those are all my patterns. If you look at all the ways that I can do this, if you count them up, there are 50 ways that you could do this situation by burgers and fries. So 50 different things that you could do here, all the way from buying nothing to buying 10 fries, which is the most you could buy. Or if you're not buying any fries, you could buy 6 burgers. So our two extremes are right here on that end, right there on that end, and then it's bordered by all of those limitations. Going back up to the last part of the problem, it says, how would your list in 28 change if you decide you wanted to purchase less than 10 items, not no more than 10 items? So which of my list here would be eliminated if I could not take 10 items? I could only go 9. So if you look at all of the things, like this would be gone because that would be 10 items. That would be gone, that would be gone, that would be gone. That would be gone. Okay, so I would eliminate 5 possibilities if I could not take 10 items. That would limit me a little bit more. So that's just an example of how linear inequalities would define something in real life. Of course, in this example, you can't buy like 2.5 burgers and 6.5 fries. So it's actually not a blanket on here like we had originally. It actually is just all of those points because of the limitations of the real world situation. So just an application for you there. Okay, that is the end of lesson 4.2.